How is CFM per ton figured? Have you ever heard of anyone throwing around CFM per ton numbers like 400 CFM per ton? What do these numbers really mean? Is it better to have more or less CFM per ton? We'll cover the conditions that impact CFM per ton on various air conditioning performance charts and how you can determine the CFM per ton. Effects of outside ambient temperature on capacity. We'll first look at the outdoor ambient temperature and how it affects the capacity of a 6-ton split system air conditioner. Here we have a chart for the 6-ton air conditioner with the 95 degree Fahrenheit highlighted in pink, and the AHRI dry bulb temperature of 80 degrees Fahrenheit highlighted in blue under each outdoor temperature, and the AHR wet bulb temperature of 67 degrees Fahrenheit and the intersecting columns and rows for these temperatures. We show 3 of the CFM settings for this chart at 1800, 2400, and 3000 CFM, which corresponds to 300, 400, and 500 CFM per nominal ton. The 2400 CFM row represents 400 CFM per ton as follows: 6 tons times 400 CFM per ton equals 2400 CFM. TC equals total capacity in MBH. MBH equals BTUs in thousands. SHC equals sensible heat capacity. If we follow the 2400 CFM row at 67 degrees Fahrenheit wet bulb temperature, you'll notice that the total capacity keeps decreasing as the outdoor ambient temperature gets warmer. For instance, at 85 degrees ambient, the AC unit provides 74.1 MBH of cooling, and at 105 degrees Fahrenheit ambient, the total capacity drops to 67.7 MBH. Fact number 1. As the outdoor ambient temperature goes up, total AC capacity goes down. If we plot these values on a chart, we can see how CFM per ton changes with the outside ambient temperature, with the air conditioner providing a constant air volume of 2400 CFM and the capacity decreasing as the outdoor ambient increases. This implies that the same amount of CFM is provided for less capacity tons at higher outdoor temperatures. Hence, the AC unit goes from 389 CFM per ton to 478 CFM per ton. So, is more CFM per ton a good thing? In this case, no, as it reflects that more air is required to be delivered for every ton of air conditioning. This is due to the air conditioner having to work harder at the elevated temperature. Most air conditioners are derated in capacity when the outdoor air temperature exceeds 95 degrees Fahrenheit. Fact number 2. As the outdoor ambient temperature goes up, the CFM per ton increases. Effects of wet bulb temperature on CFM per ton. When the indoor wet bulb temperature increases, the CFM per ton of an air conditioner system typically decreases. As the indoor wet bulb temperature rises, the system may need to increase its airflow rate, CFM, to maintain the desired indoor temperature and humidity levels. Fact number 3. As the wet bulb temperature goes up, the CFM per ton decreases. There are 2 ways to look at CFM per ton. One is based on total load, the other based on sensible heat. The system's sensible heat ratio, SHR, represents the ratio of sensible cooling, temperature reduction, to total cooling, temperature and humidity reduction, or sensible heat capacity, SHC, as shown on this chart, represents the BTU per hour capacity of the system at the stated condition. Let's look at the effect on sensible capacity when the indoor wet bulb temperature changes. A lower SHC means that a greater portion of the cooling capacity is dedicated to removing moisture from the air rather than reducing its temperature. We can see by this performance chart that as the indoor wet bulb temperature increases, the sensible capacity decreases. This means that based on our 2400 CFM and the sensible capacity only, our CFM per ton increases as the wet bulb temperature increases. This is the exact opposite of the results we get from CFM versus total capacity. Because the system uses more of its capacity for removing moisture, there is less left over to remove sensible heat. This is why it's important to understand the latent heat load generated within a room or brought in for ventilation air or by infiltration. Fact number 4. As the wet bulb temperature goes up, the CFM per ton increases based on sensible heat only. Reading air conditioning performance charts. Here is a different manufacturer's performance data for their 6-ton air conditioner. As we already learned in the previous examples, as the outdoor air temperature increases, the system capacity decreases. Notice also, as the outdoor temperature increases, the high side pressure increases from a low of 275 to 527 psi. Also note that the higher the moisture content, or the wet bulb temperature, the greater the system pressure. The hotter it gets outside, the higher the system pressure. As the high side pressure goes up, the low side pressure follows. Fact number 5. Higher outdoor temperatures increase discharge and suction pressures. 400 CFM per ton rule of thumb. The 400 CFM per ton rule of thumb is a commonly used guideline in the HVAC industry to estimate the airflow requirements for air conditioning systems. It suggests that for every ton of cooling capacity provided by the air conditioner, approximately 400 cubic feet per minute CFM of airflow should be delivered to the conditioned space. This rule of thumb is based on a combination of engineering principles, empirical data, and practical experience in the design and operation of air conditioning systems. While it is widely used as a general guideline for estimating airflow requirements, it is important to note that actual airflow needs may vary depending on factors such as climate conditions, building characteristics, equipment efficiency, and occupant comfort preferences. The 400 CFM per ton rule of thumb is intended to provide a starting point for HVAC designers and engineers to estimate airflow requirements during system design and sizing. However, it is not a substitute for detailed engineering analysis and calculation, and it should be used with caution, taking into account the specific requirements and constraints of each project. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.